Hi viewers, welcome to Usman Chayin Physics Maths class. In our tutorial today, I shall continue with the discussion on radioactivities. In my last video, I have discussed on the relationship between the decay constant and the half-life. And as I promised that in our next video, we'll be looking at the examples. So in our present video today, we'll be looking at two approaches to solve this very example. The first method, we're going to use the equation that we have proven to solve the example, while the other is what we call the Z-pole method. We'll use the Z-pole method and see how we can solve this same problem. So you will not have a choice to find out which of the method is simpler. Okay, so if this is your first time watching this very video, I encourage you to go to YouTube and subscribe to Usman Chain Physics Maths. Follow Usman Chain Physics Maths class on Facebook and TikTok so that you should enjoy the whole of the video. So let's get into it quickly. Solution: a radioactive substance of mass 768 gram. So it means that N node is equal to 768 gram, okay, has a half-life of 3 years. So it means half-life is equal to 3 years. All right, after how many years does this substance leave only 6 gram on decay? So it means that our end is equal to 6 gram and the time taken is equal to question mark. All right, the time taken is equal to question mark. So we quickly remember our equation. We have to fold back the equation immediately. The equation is end equal to N naught e raised to power negative lambda t. That is our equation. So if that is true, our N is 6 equal to the N naught is 768 and e raised to power negative lambda t. Remember that t is not given. T is not the half-life. It's not something as half-life. So if I want to, the next step I supposed to do here is to what? Divide through by 768. So we have 6 over 768 will be equal to e raised to power negative lambda t by dividing through by 768. So if I want to remove this negative sign, I'll take the reciprocal of this. So taking reciprocal of this, I'm going to have, if you take the reciprocal of this, you're going to have 768 all over 6. It will now be equal to e raised to power lambda t. The negative is no longer there. All right, so 768 divided 6, we're going to have 128 equal to e raised to power lambda t. All right, so from here, if I want to remove the e, I'll take the length to both sides. So I'll have length 128, it will be equal to only lambda t. This natural log has disappeared. Okay, so the length of 128 is equal to 4.85. We take this length, this is what we're going to obtain, so it will be equal to lambda t. We are looking for t, so we have to divide through by lambda, so that we have our t should be equal to 4.85 all over lambda. All right, so if that is true, we have to fall back to what we have proven in the last video. We said that the lambda is equal to 0.693 all over half life. That was what we said in our last video. So we will substitute this into this very equation. Instead of writing lambda, we'll write that. So this is equivalent to, we can say t will now be equal to 4.85 divide 0.693 all over, our half-life is given as 3, so all over 3. And this is same thing as 4.85 over 0.693 multiplied by 3. And this will going to give us 20.9985. So if you approximate it, it means that T approximately will be 21 years. And that is the time taken. It will be what? 21 years. So now that this is using the formula method that we have actually proved. So let us look at the ZPO method. The ZPO method. We want to use this method now in solving this very particular problem. In ZPO method, we have T is equal to small t all over log 2 raised to power r, or log r base 2. Okay, so we have to define this thing. This t is now half-life, and this is the time taken, and this is called the disintegrating ratio. The r is called disintegrating ratio. So the disintegrating ratio r is given by end node over end, and this will be, our end node is 768, all over n is 3, so this will give us a 128. Okay, so it's going to give us 128, 128. Okay, so we'll substitute it into this very equation. When you substitute it into this equation, we have the half-life is 3, so we have 3 equal to t all over log, the r round is 128, and the base is 2. Okay, so if that is true, this 128, there is a way we can write it. Okay, there is a way we can write it. Okay, so sorry for that. So we have 3 equal to t all over log 2 raised to power 7 base 2. And when you have something like this, the 7 will fall back. So we have 3 equal t all over 7 log 2 base 2. And log to its base is equal to 1. Alright, so we have 3 equal to t all over 7, because log to its base is 1. 1 times 7 is 7. So our t will cross multiply, it will be 7. This 7 will multiply this, so it will be 7 times 3. So t is equal to 21 years. So